So the next type of power that we're going to get into as a geological resource, remember water is a resource, right? We're going to hopefully pick that stuff up back at the end of the semester. But I want to take a second and talk about hydropower. So getting energy from water. Now this is really actually something we've been doing for a very long time. It turns out it's pretty rudimentary. Although we haven't always been generating electricity from water. So you probably all seen a water wheel at one point in your life. And if you think about what a water wheel does, there's a couple of different types of water wheels. But essentially it creates a rotational force. So I'm going to draw a quick picture of this like basic water wheel and think about how that would work. Again, I've drawn an incredibly rudimentary sketch here, but this is kind of a pour-over style water wheel. And you would take water, divert it from a nearby creek or stream, and you'd pour it onto your wheel. The weight of the water only on one side of the wheel will cause this thing to turn. Towards the bottom of the wheel, that water dumps out and runs off in a stream or something like that. So you've used weight on one side of this wheel to kind of keep it consistently turning. So you have a rotational force. And remember, we've been talking about energy, right? So we haven't created electrical energy. But then in my diagram, I've drawn this just as a wall. So this would be the wall of a building, whether it was a lumber mill or a bread mill, like a grain mill, or a machine shop. There's all kinds of crazy stuff that you can do. And fundamentally, this is how it works, right? You can see that you have your rotating axle, and you can put, some gears on here. You can strap belts to it. All sorts of things you can do once you get inside that. So again, let's take a look at a couple of pictures here. You can see again, pretty typical water wheel, where one side of the axle runs through this wall into the building, and inside of the building, it's doing work in this rotational sense. Here you can see another example. I think this one's in France, and this isn't the pour-over style, right? This is the style of water wheel where the bottom of the water wheel is just in a flowing channel, right? So it just turns as the water flows by. On the inside of the building, you may see something like this. So remember, the ones that comes through the wall, all of your work is ready essentially as a turning axle. So again, this is pretty antique technology, but important. So here you can see the inside of a mill. Again, kind of the big three are a lumber mill, a grain mill, and then kind of a machine shop, which we'll take a look at. And so essentially all you have on the inside is this rotating axle. And all it does is provide a rotational force again. So what you can do on this end, as I was mentioning, you can kind of hook a gear. One of the more common things to do is actually to do this with a series of belts. So we'd have a belt tied to our main axle here, and that belt then runs up to the ceiling of the shop. And then from there, this is what's called a line drive shop. So there's essentially an axle along on the ceiling, and it's also rotating because it's hooked to the drive of the main water wheel. It can be clutched, right? So the speed can be adjusted pretty easily. And then from there, individual belts run down to run individual machines. Obviously, this isn't something that we do all that much in the modern world, but you can see again, some pretty complicated shops, like machine shops, can be run this way. And you can see here, this is a great image. This is actually in Sweden. It's kind of a historical park you can go and visit. And they have an entire machine shop that runs on line drive like this, and you can see up at the ceiling. And so all you would need was one big water wheel to do this. It has incredible torque. And again, on each individual machine, you can kind of clutch up and clutch down and change the gear ratios so it runs faster or slower. Pretty interesting technology. But, whether we're sawing wood or grinding grain to make flour or making, a litany of objects in a machine shop, none of those are using the power of the water for electricity. And so that's what we do in the modern world. And the simplest way to think about this is what we call hydroelectric, right? So hydroelectric is we put a dam on a river, right? The type of hydroelectric that probably pops right into your mind's eye when we started this discussion. Well, this is a pretty poor drawing, but hopefully you can understand this. We'll show you a kind of figure that I was copying when I did this. But what we're using really in the case of hydroelectricity is the difference in elevation of two different packages of water. So we know that water flows downhill. That's what it's doing in rivers. And we're essentially interrupting that, taking advantage of it, and using that to spin the magnet. So the way that this works is we would put a wall, right? A giant structure which impounds the water. That's the dam itself. And then under that, there's this pathway called the penstock. And that's the direction that the water flows into the hydroelectric facility itself. So in Idaho, we actually have a lot of dams that don't generate power. They're used for things like irrigation and stuff like that. That's a different story. Here we're going to actually have this water that comes through the penstock. It's going to then hit our turbines down here. And when it hits these turbines, it spins them, again, very similar to blowing on a pinwheel as a child, right? And the pinwheel spins. That's then tied to an axle, which runs up into our generator. We've pretty much seen this story before. In the past, we used steam to do this. Here, we're just using the flow of water to spin that turbine. It produces power in the generator, and then out of our electrical generation facility, we actually have power that runs off, and then this wastewater is kind of caught back up in the downflow side. So here, this is a version of this image that's much easier to understand, although it's fundamentally the same thing that I drew. Notice that there is, on the upstream side, like a little mesh to protect you from logs and things like that from getting in and damaging the turbines. But this is really straightforward. And we've been generating electricity in the United States this way, really from the get-go, right? From the early 1900s, when we started using electricity widely, we began generating electricity with hydroelectric technologies, particularly out east. But we do a lot of it out west as well. Now, the west is big time when it comes to hydro. As you can imagine, the hydroelectric scales, right? Depending on the size of the river and depending on how much water you're impounding, that's going to determine how many turbines you can move with the flow of water. So this is a dam that's near and dear to our hearts. This is Swan Falls Dam, which is about 15 miles south of Kuna. So it's probably the biggest hydroelectric facility in the region. Although one of the things that we'll explore is that it really doesn't generate all that much electricity. It generates a similar amount of electricity as a handful of wind turbines. But we'll kind of meet that on the backside of the discussion. So at Swan Falls Dam, you can see it was built in 1906. We've really been using this thing for quite a while. In this picture, when you see these beautiful buildings, those are actually no longer functioning. Those are just a museum. So you can go in there and see some things like turbines. And kind of to the right of those buildings, you can see a little kind of concrete box. That was installed in the mid-1990s. And that really is the functioning part of the modern dam at Swan Falls. That's where the turbines are. Here, just a general thought, I wanted to kind of highlight what these turbines are doing. Hopefully you remember from our drawing that a portion of this is kind of underground inside of the dam itself. That's the turbine. You can see this diagram has water flow labeled there. It also has a little person for scale, but you likely wouldn't be able to stand there. There's a floor that's going to separate the generator and turbines. So the generator will be above ground. The turbines will be down in the kind of interior of the dam. But this is how it works, right? This is how it spins the magnet. These are the turbines out of Swan Falls. I mentioned that the old portion is actually a museum. You can go see. These are the turbines that were brought in the early 1900s. But that's a really small application, right? So Idaho Power touts Swan Falls Dam, and we do generate a significant amount of hydroelectric energy in Idaho. We sell most of it on the open market, which is just how it works, right? That's how the power system works. If we bump over one state and we start looking at Oregon and Washington, the amount of capacity for hydroelectric that they have is way more. The Columbia River, massive amount of water, a massive amount of power. So this is, you can see here, this is an image of Grand Coulee Dam. Grand Coulee Dam is the largest dam on in the Columbia system of the Columbia Gorge Dams. There's kind of a family of them, Bonneville, Condit. I think one other I'm blanking on right now, but Grand Coulee is the biggest of the big. And you can see there's an incredible amount of water held back. There's a kind of emergency spillway. And these things generate a significant amount of power. The largest dam in the world, in the term, like purely hydroelectric, is the Three Gorges Dam that was built in China not all that long ago, about 15 years ago. And you can see this thing is massive. And the generator rooms associated are also massive. You can see there's a person on the far left for scale here. But the technology in what I would call kind of conventional hydroelectricity is really simple. Remember, one of the catchphrases we've been throwing around over the course of this class is spin the magnet, spin the magnet. How do we do that? And here it's really obvious, right? So the technology that we've been using to saw lumber, to grind grain for bread, and to run a small kind of mechanical shop, a drill press or whatever we need to do, we've been using that technology for a very long time. We're really just kind of modernizing it, and rather than turning an axle and just using that axle to do work, we're turning that axle and we've essentially stuck a magnet on one end of it and are creating electricity. So again, this technology was really kind of lowbrow in a sense. And many people see this as really clean energy. We'll see that's not entirely the case. There are definitely some problems associated with hydropower, but we'll explore those towards the end of this series of talks.